You are welcome. We are going to discuss logarithms. The logarithm of a number a to a base b is the number to which b must be raised to obtain a. i.e., if the log of a to a base b is equal to p, then a is equal to b raised to power p. The base b must be greater than 0. The base b must always be greater than 0. E.g., the log of 100 to the base 10 is equal to 2, because when you raise 10 to 2 to give us 100, in this case a is equal to 100, b is equal to 10. Remember we said the logarithm of a number a to a base b is a number to which b, remember that b is the base, the number to which we must raise the base b in order for us to get a. So in this example here, a is 100 while b is 10, meaning we must raise this number 10 to the power 2 before we get 100. So the logarithm of 100 to the base 10 is 2. The next one, the logarithm of 8 to the base 2 is equal to 3, because we must raise 2 to the number 3 before we can obtain 8. Also, the logarithm of 1000 to the base 10 is still equal to 3, because we must raise 10 to the power of 3 before we can obtain 1000. The same thing also goes for the logarithm of 0.5 to the base of 2 is equal to -1, because we must raise 2 to the power of -1 before we obtain 0.5. So these are just few of the examples. Next, we are going to discuss few laws of logarithms. Laws of logarithm. The first law we have here is the law of addition, or the law of multiplication. If we have that the log of a to a base a plus the log of b to a base b is equal to the log of ab to the base a. I mean, when we are adding it, but the base must be the same. When we are adding it, then it becomes multiplication. The same thing also goes when it is minus, it becomes division. When we subtract, it turns to division. Also, the log of a number raised to a power b to a base a is equal to b log a to the base a. The log of a number a to the base a, that is when the number and the base are the same, is always equal to 1. You can try it for yourself. You can check for log 10 in your calculator in base 10. It's going to give you 1. The next one is the log of 1 to any base is equal to 0. You can try log 1 in your calculator. You will see it to be 0. The next law we have here is when the log of a number a to a base a raised to power b. That means when the power is in the base, we're able to have 1 all over b log a to the base a, meaning the power in the base will go to the front with, and it will become a fraction, the inverse of the power of a in this case, which is 1 all over b log a base a. The next one is what we call change of base. This law is used to change the base of a log. If we have that log a to the base a, then this will be equal to log a to the base b all over log a to the base b, meaning that we have changed. Remember, small letter b, we have changed. In this case, a is up, a new base was introduced, which can be any base. A new base b, you remember that b is always greater than 0. B cannot be 0, always greater than 0, and it cannot be negative. Therefore, we have that log a to the base b all over log a to the base b. Then the last but not the least is log a to the base a is equal to 1 all over log a to the base a. Therefore, we move on to solve some few examples. Before we continue, please like this video, share this video, support this channel by subscribing to help this channel, to help YouTube to give our content to other viewers who also need it. Next, the first example we are going to solve here is express x as a logarithm to a base a. The first one is a raised to the power 2 minus 3x equal to b. We want figure 2 is a raised to the power 2x equal to b. A raised to the power 2 minus 3x equal to b. To solve this, remember that for what we did from when we defined logarithm, which is this, we said that if log a to the base b is equal to p, it means that a is equal to b raised to the power of p, which means that the p will just come here and become the base, while the p becomes the power. The same thing will be done here while we introduce the logarithm. So if you compare it with what you just did now, to make it easier for us to understand, I'm going to rewrite it by saying b is equal to a to the power 2 minus x. So when we introduce log to b, I have log b. Remember that, look at this place. What happened here with the log? Have you seen it now? With the log, if I introduce log, let me say I introduce log here now. Log a, this b will come back to its position. Then we have p. For us to get this back. Have you seen it? So the same thing will be done here. So a will become the base, and it will equal to 2 minus 3x. So the same should express x. So we are going to make x the subject of the formula. So this becomes, bring this there, bring this there. We're going to have 3x is equal to 2 minus log b. So we are going to divide both sides by 3. X will be equal to 2 all over 3 minus 1 all over 3 log b. So this is the first expression for x in the first one. Let's also solve for the second one. Solving for the second one, which is a raised to the power 2x equal to b. We're going to do exactly what we did there. To make it easier, we take b to this side, then introduce log b. A will become a equal to 2x. We're going to divide both sides by 2, so x will be 1 all over 2 log b a. That is that. Now let's solve the other question, which says if log 2 base 5 is equal to 0.431 and log 3 base 5 is equal to 0.682. Find the values of number figure 1 log 1.5 base 5, number figure 2 log 1 over 4 base 5. To do this, we have that log 1.5 base 5 is equal to log 1.5 is the same thing as 3 over 2 base 5. Also, from the laws of logarithm, which we wrote earlier, where we have this log a over b to the base a, it is equal to log a base a minus log b base a. Therefore, we are going to have that log 1.5 base 5 is equal to log 3 base 5 minus log 2 base 5. But we were given in the question that log 3 base 5 is equal to 0.8, that log 3 base 5 is equal to 0.682. Therefore, I'm going to write 0.682 minus, then we have that log 2 base 5 is equal to 0.421. Therefore, our answer will now be 0.2251. This is our answer, which is very, very easy. So we have done the first one. We are going to proceed to do the second one, which is log to the base 5 1 over 4, and this gives us log to the base 5 of 1 all over 2 square. Remember, from what we did here, we have that log 1 base 5 minus log 2 to the power 2 base 5. This gives us log 1 base 5 is 0. From our laws of logarithm, the law of 1 to any base is 0. Then we have that minus 2 log 2 base 5. This gives us log 2 base 5 is equal to 0.431. Therefore, I'm going to have minus 2 into 0.431. When we multiply, I'm going to have minus 0.862. This is the answer to the question. Thank you very much for watching up to this point. If you enjoyed this video, please like this video, share this video to your friends. Please subscribe to this channel. I will see you in the next video. Bye for now.